Today we are having revision for electrostatics. All right. So first of all, electrostatics definitions we should know. It is number one. Electrostatics defined as static electricity or stationary electricity. It's number one. And then we have charged object, neutral object, positively charged object, and negatively charged object. Neutral object means number of protons and number of electrons same. And positively charged, we have more protons. Negatively charged, we have more electrons. And transfer of charge, so we have charging by friction, charging by conduction. Charging by friction, you rub two objects, each other, and then electrons moving from one to another. Electron transfer from wool cloth to plastic rod, and electrons transfer from glass rod to silk. So charging by conduction, when you have two objects, charged objects, when they touch each other, this is your total charge Q1 plus Q2. Q1 plus Q2 over 2, giving you final charge, new charge after rubbing each other. All right. So, and then what else we know? Like charges repel each other. Unlike charges attract each other. So between these two, we have repulsive. If you have positive, positive, negative, negative, we are calling repulsive electrostatic force. If you have unlike charges, attractive electrostatic force. Polarization. Polarization between charged object and neutral object. This is our process. Full process is here. You can just check from here. And you have neutral object initially, and then all positively charged object attracting electrons one side, and then protons left other side. Only electrons moving, remember that? Only electrons coming this side, and then only protons left other side. And then if you do same process with negatively charged, of course, electrons going to other side. And then you are making polarization, and then they attract each other after that. Conservation of charge, total charge never change in a closed system. Total charge never change. Let's say the electric charge is always, electric charge is always conserved in an isolated system. You can say total charge, they touch and separate from each other, and then you are gonna see final charge never change, total charge always same. All right, unit of charge is coulomb. Last lesson also we have done that. And the quantization of charge, there's another definition. Depends on number of electrons, what you have in your object. Definition of elementary charge, charge of electron. So this is our first formula for this topic. Other formula also we have, just adding and divide by 2. So Q equals N times QE. Okay, let's write our formula, all formula one side, and then we are going to use them. So first of all, Q final equals Q1 plus Q2 over 2, and then Q equals N times QE. So far we have these two formula, and okay, we can clean up, it's fine. Examples with solutions. All right, so we have quantization of charge, conservation of charge, polarization, different charges, neutral, positive, negative, and this all done. Okay, from now, let's continue with questions, examples with solutions. We are using this one because we see questions and answers, because it is a revision lesson. We cannot go through all details. So, okay, question 1, example 1. So, when you have two charged objects, -6 coulombs, -2 coulombs, when they touch each other and separate from each other, so what you are going to get, they're going to have same charge. Okay, let's check what they ask now. Direction of electron transfer, they're asking you. To get direction of electron transfer, you must just check which number is small. Okay, small number, less number. As you see, -6 less than -2. If just you can use number line 0, -1, -2, -3, -4. You don't need always drop, just to understand. negative 5, and negative 6. So negative 6 is less than negative 2. So electrons moving from A to B. All right. So you must just use less than. But if they ask you reason, you must just say from more negative to less negative. All right. Next question, they ask you how many electrons are transferred. All right. How many electrons are transferred now? We should calculate our final charge first. Q1 plus Q2 over 2. Negative 6 plus negative 2 over 2, getting negative 4 coulombs. This is your final charge. And then you are getting change in charge, delta Q. We are calculating Q final minus Q initial, minus 4 minus 2, negative, making positive. And then you are getting negative 2 coulombs. This is your delta Q, change in charge. So delta Q, you can write delta Q, or you can leave it with this formula. So if you want, you can use this formula also straight. From Q equals N times QE, you can write N equals delta Q over QE. For Q delta Q, we can write Q final minus Q initial over QE. And then your Q final is, as you see, you just calculate negative 4. Negative 4 minus negative 2. For Q initial, you can use Q1 or Q2. It's up to you. For now, we are using Q2B, negative 2 we are using, and divide by 1.6 times 10 to the power of negative 19. So negative, so this is making positive to negative making positive 2, and negative 4 plus 2 making negative 2 over negative 1.6 times 10 to the power of negative 19. So you must use negative for this, and then you are getting answer. But if you say you want to use Q1, so let's see what's going to happen now. What's the difference now? Same result we will get, but some calculations different. So delta Q, Q final minus Q initial over QE. Now Q final is negative 4 and minus 6, negative 6 over QE. So 1.6 times 10 to the power of negative 19. Now we are going to use positive for this, because negative 4 and negative making positive, you know that, over 1.6 times 10 to the power of minus 19, because on top you are getting positive 2. Positive 2, and then you are using positive also for charge of electron. Charge of electron change to charge of proton means. So negative 19. All right. So you are getting your results with two different methods. So you can use delta Q. If you want just with this one here, you can calculate delta Q first and then put in this formula and calculate. It's option 1. Option 2, I'm using Q initial. For Q initial, I'm using Q1. Option 3, for Q initial, I'm using Q1. Q2, Q1, you can use different. So this is our first question. Second question, similar question. So even we don't need to explain more, just quickly let's show it. So direction of electron transfer, what we said, from less number to big one. So less number is 0 coulombs. So from 0 coulomb to plus 2 coulombs, it means A to B, done. All right, direction of electron transfer, just check numbers, which one is smaller than other one. So you are just writing direction like that. And the next one, Q final, they ask you how many electron transfer, same steps. Q final, you are calculating, delta Q you are getting, and then Q equals N times QE, plus 1 is equal to N times QE. But remember, you have positive here. You are using positive for QE also, because N is equal to delta Q over QE. If your delta Q is positive, QE also positive, or you can use this one. So this is our number of electrons transferred. Let's continue with next one. So next question, when they coming together, they contact and separate. So plus 2, plus 4 now. So asking you, same questions, direction of electron transfer from A to B. Why? Because we have positive 2, positive 4. positive 2 is less than positive 4. And then asking you how many electron transfer. Sometimes they ask you what is final charge when they touch each other. You can just use this formula. Sometimes they ask you how many electrons transfer, just like this, step by step, you should answer. So Q final we are calculating, and then delta Q, it means change in charge, we are calculating. After that, we are getting number of electron transfer, but I like this way, N equals delta Q. After getting Q final, I'm using this way. It's much better, much easier for me. For you, I don't know which one is better. So Q final minus Q initial over QE. Q final, what we have now? 1. 1 minus Q initial. Oh, sorry, Q final is 3. Okay, 3 coulombs. 1 delta Q. Okay, 3 coulombs for Q final. 3 minus, let's use 8. 3 minus 2 over 1.6 times 10 to the power of minus 19. So N is equal to 1 over 1.6 times 10 to the power of minus negative 19. All right. So as you see, we have positive here for N. All right. So just like this, all questions, electrostatics, one more revision with you. Okay, now we have two charged objects A and B plus 8 N. C, N is nanocoulombs, 10 to the power of negative 9. We'll write it now. And then you have negative 4 NC. Question 4.1 asking you what type of force between these two. Okay, attractive or repulsive? What we know, if you have attractive means, if you have different charges, positive, negative, so they are attractive electrostatic force. So, as an answer we can show here, as we see question 4.1, attractive electrostatic force. Why? Because you have positive and negative charge. All right. And then it is attractive electrostatic force. Now, question 4.2, they touch and separate from each other. So, if you do that, 4 to 1, they're asking you what type of force between them. Now you have repulsive electrostatic force. Why? Because when they touch, they're going to get same charge. Which charge they are getting? Final charge. It's here. We just calculated here. 2 times 10 to the power of negative 9 coulombs. It means 2 NC. All right. When they touch each other, getting 2 NC. All right. So getting same charge. Always when they touch, getting same charge. Okay. Next question. Direction of electron transfer, of course, from B to A, because B is negative 4, A is positive 4. So from B to A, moving from B to A. Next question, same question, calculate the number of electrons transfer. So our steps, you know already, Q final first, Q1 plus Q2 over 2. Let's write Q1 plus Q2 over 2. And then Q1 is plus 8 times 10 to the power of negative 9. How we know it's negative 1? Because you have NC. All right. So let's remember our units, all converting units. If you have picocoulombs, let's say 5 picocoulombs. Picocoulombs is equal to 5 times 10 to the power of negative 12 coulombs. If you have 5 nanocoulombs, just like this one here, 5 times 10 to the power of negative 9 coulombs. If you have 5 microcoulombs, 5 times 10 to the power of negative 6 coulombs. And then if you have millicoulombs, milli-C, 5 times 10 to the power of negative 3 coulombs. We have kilo also, 5 kilocoulombs. You can use this one for coulombs, for ampere, for voltage. You can use for any unit. These numbers we should remember. P means 10 to the power of negative 12. N, 10 to the power of negative 9. Micro, 10 to the power of negative 6. Milli, 10 to the power of negative 3. And then 5 times 10 to the power of 3 coulombs. And then 5 kilo done. After that, mega million coulombs. 5 times 10 to the power of 6 coulombs. And what else we have? Giga. 5 GC. 5 times 10 to the power of 9 coulombs. And then we have 5 teracoulombs. Teracoulombs is equal to 5 times 10 to the power of 12 coulombs. All right. So we have done this question also. As you see, what we have, what type of force between them? If you have different charges, positive, negative, attractive electrostatic force. If you have same charges, repulsive electrostatic force. And then when they repel and attract each other, you must just check the charges. And the direction of electron transfer from less number to big number, so larger number, so just like that. Okay, and from now we have more questions. In other lesson we can answer this question. We answer already. You can go to playlist and you can get more solutions about this one, more questions we did answer. So for finalized electrostatics, so you have past papers. Yeah, past paper questions also we can answer in other video. Today just revision, quick revision we have done. So we have this formula. Let's just get a page like this. Okay, we have this formula. Number one, Q equals N times QE. Charge, if number of electrons given, asking you what charge on this object. Let's say object A. Charge is given, so number of electrons given, for example, N equals 5 times 10 to the power of 10 electrons. Okay, number of electrons we know in that object, so asking you charge. Okay, this is first option. So first type of question, N times QE. N is what? We can write 5 times 10 to the power of 10. It is number of electrons times charge of electron. What we have, it is charge of electron, yeah, 1.6 times 10 to the power of negative 19 coulombs. When we calculated 8 times 10 to the power of negative 19 coulombs. But you are using negative or positive here, you must just check your question. If they said excess electrons, so getting electrons, it means negative. Losing electrons, getting positive. Okay, let's see that kind of questions here in our examples. See, an object excess 50 electrons. What is charge on the object? Okay, let's try to see all types of questions quickly. So about this one. So now you know number of electrons. So what you are going to do for this question, Q is equal to N times QE. And let's write bigger. Q equals, N is 50 times 1.6 times 10 to the power of negative 19 coulombs. So 50 excess electrons, so it is negative. So 50 times 1.6, what are we getting? Just what we're getting, 80. So we can use, okay, 8, negative 8 times 10 to the power of negative 18 coulombs. Okay, this is our first type of question. Other question, charge can be given, and then they can ask you, charge can be given, and then they can ask you number of electrons. So that kind of questions, if Q equals N times QE, from this formula, how can we write number of electrons formula? Q over QE. By using this, you can get number of electrons in that object if you know charge. Okay, and then what else we have? You have two charge objects, Q1 and Q2, object A and B. When they touch and separate, what's your, let's say, net charge? Okay, net charge, Q1 plus Q2. If they ask you final charge after touching each other, you can use this formula, Q1 plus Q2 over 2. And then if they ask you number of electrons transfer, N is equal to delta Q over QE. Delta Q is Q final minus Q initial over QE. And then N is equal to what we have, Q final is, for Q final, what we have, just you are going to just calculate Q final and Q initial. Okay, we are not answering question, just giving formula. All right, so for electrostatics, we have this formula for grade 10 level. So when you go to grade 11, of course, we have more. We can continue, we can answer more questions. But for today, it is more than enough. So just we are having revision. For other past paper questions, please go to other videos, revision questions, and then just other questions you can get from other videos. All right, we have done for today. Good luck for your exams, everything. See you next lesson. See you next video.